so we are ready. We did a really, really basic problem. It was kind of a review, actually, last time. So this time, we're going to do a little bit tougher problem, but I still think it's quite manageable for you. What do you think you're going to do first? We are on page 30, problem 1B. What are we going to do first?
Get the asymptote.
Well, we're going to factor everything, right? Now, if things factor, you should always factor, because if you can cancel things, there's a significance to that we're going to talk about in the next problem. You're going to have removable discontinuities, right? So you always want to check the factoring. In this particular problem, nothing's going to cancel. But in the factored form, it is easy for me to see where my vertical asymptotes are going to be, right? Where are my vertical asymptotes going to be?
2
At 2 and negative 2. So 2 and negative 2 are my vertical asymptotes. Because one more time, vertical asymptotes happen where the function is undefined, where the denominator is 0. Right. Now, let's look at the original problem. I think it's easier to look at that for my horizontal asymptote. Where's my horizontal asymptote? Y equals 1, right? Now, I am still calling it a horizontal asymptote, and that's really a bad habit for me to be in, because it's technically an end behavior asymptote, which means even though I've drawn it all the way across the page, the asymptotic behavior is at the ends. Okay, that's important. The horizontal asymptote is an end behavior asymptote. So the approach is going to be out here. I don't know what's going to happen in the middle, and it doesn't matter. This is an asymptote only at the ends. All right, let's get the intercepts in there. To find the intercepts, remember we let each coordinate be 0. So if we let x be 0, our y-intercept is going to be at 9/4. Everybody okay with that? And then if we let y be 0, keep in mind that your denominator is going to disappear because you're going to multiply it over here and it's gone. So aren't you really just solving the numerator? So your intercepts are at 3 and negative 3. Would everybody agree with that? Okay. Now, at this point, all the important stuff is in there, and we have to draw the picture. So if you can do that at this point, go for it. If not, plot a couple of extra points if you're not sure. So, sir, you're like over here going like this. What do you think?
So at the 9/4, that would be the vertex of a parabola.
So it's going to have a shape something like this, right?
And then it'll be the curve that way, and another curve oriented that way.
Now, does that make sense to everybody?
Yep.
If it doesn't, then plot more points, okay? So plug in 4, plug in 5, plug in 1, plug in negative 1, and just see what happens. Plot those points. Well, that wasn't too bad. Everybody okay with that one? Because now things are going to get a little bit more exciting. I know it's hard to imagine. Alright, so let's try the next one. What are you going to do right off the bat with this next problem? You're going to factor it, that's right. And so Sir says in terms of factoring, I can take an x out of my numerator. So that leaves me with x squared minus x minus 2. And actually my denominator factors plus 3 minus 2. My numerator factors some more. X minus 2 plus 1. me double check that. Did I factor correctly?
Yeah, looks good.
Okay. All right. Whoa, what do you notice? We can cancel, and our problem is now x plus 1 over x plus 3.
Mm-hmm.
So this is what I'm now factoring, okay? Or not factoring, graphing. This is what I'm graphing, this equation right here. But I have to remember that in the original problem, there was this factor, right? I removed it, so it's gonna graph as a hole in the picture where x is 2. Now, the hole is a point, please don't put an asymptote at 2. It's a hole, it's an open dot. What is gonna be the y coordinate of that dot?
Would you plug 2 into x?
I plug 2 in right here. Do not try to plug 2 into the original problem, it won't work. You get a 0 in the denominator, you gotta plug 2 in here. So if I put 2 in, I'm gonna get 2 times 3 over 5, did you get 6/5?
Yeah.
So on my picture, at 2 6/5, I'm gonna have an open dot. Now, what about a horizontal asymptote? Is there a horizontal asymptote in this problem? Or not horizontal, vertical. Is there a vertical asymptote in this problem? There's a vertical. It's at x equals -3. Now, keep in mind that if you multiply your problem back out, it'd be x squared plus x over x plus 3, right? If we multiply this back out, is there going to be a horizontal asymptote? No, because the power on top is bigger. However, there is an end behavior asymptote. It's going to be a slant asymptote, not a horizontal line. It's going to be some kind of slanted line. Anybody remember how to find it? What do we do to find a slant asymptote? You did this last year. Do you happen to remember? Ben?
You divide that out and the linear equation is
You
the same.
actually divide it out, that's right. So this is like a synthetic division problem, right? We're gonna actually divide it out. So, in my box, we'll go a -3. And this is gonna be 1, 1, 0. And here we go. Check my division. I am really tired today, you guys. This week has worn me out. Is that right? Okay, so what would that quotient be? That quotient down here, what is that?
1x minus 1
So
2.
it's,
X minus 2.
so it's x minus 2, and then that remainder, that 6 is a remainder. For purposes of the slant asymptote, we don't care about the remainder. The slant asymptote is y equals x minus 2. So your asymptote, your end behavior asymptote, is the quotient part of the division. Okay? It's the quotient part. So now I'm going to graph y equals x minus 2, which is a line, y-intercept -2, and a slope of 1. Now, what about intercepts? Let's go back to our reduced problem. What is the y-intercept? Might be easier to look at it here. If you put in zeros for the x's, what are you going to come up with?
0.
0. Aren't you just going to get 0? Origin. What about x-intercepts? Remember, to find x-intercepts, you basically just solve the numerator. So we got 0, which we already have, and we have -1. -1. Good Lord. This crazy. I think I'm gonna plot some more points. I think I'm gonna start with, I'd like to know what happens right in here. So I'm gonna start with -1/2. Now here's the good news. The good news is, I just wanna know if -1/2 gives me a positive number or a negative number. Because these two dots have to be connected, you understand that? So they're either connected above or below. I don't really care what the value is, I just need to know if it's gonna be positive or negative. So if I put in a -1/2, I'm gonna get -1/2 times a +1/2 over a +2.5. Is that gonna be a negative number or a positive number? It's gonna be a negative number, so these are connected this way. Now, that dot is part of the curve. So I'm guessing it looks like that. Now, you probably have an idea about what's going on here. Do you think it just keeps going up like that? You don't think so? I think so. I think so. But if you're not sure, what can you do if you're not sure? Yep, put in -2. You put in -2, you're gonna get a negative times a negative over a positive. That's a positive number, so it's gonna go up. Now, where's the other piece of the problem? There's two pieces. Remember how when there's one vertical asymptote, there's two pieces. There's something on the left and something on the right. Where's that other piece? I've got the right piece is right here. Where's the other piece? It's right down here. It's right down here. Now, before anybody says, oh my gosh, how do you know that, Mrs. Ward? I want you to remember that you have already plotted the intercepts. So, this is an end behavior asymptote. If you were going to draw your other shape in this area, you see that right there? That's not allowed. You can't cross the axis except in the places that you have already designated. So you really don't have any choice, kids, other than to put it down here. It really can't be anywhere else. But if you're at all unsure, plot some points. Wow, that's pretty cool. All right, okay, let's try the next one. Oh, Lordy. Let's try the next one. Look at this one. Okay. At first, Sir thought maybe we could factor by grouping. Well, you can't do the first two and the second two. You actually could do the first and last as the different, or the sum of cubes, and the middle two. But it might be just easier to, let's just guess something. I'm on D. Yeah, I'm on D. So I'm ready for D. So I'm trying to factor that top. I think -1 works. Maybe not. Let me check. Let me just check and see if this works. No, there's one work. No. Oh, crap. I thought it factored. Aren't 1 and -1 my only options? Did I make a mistake? Only rational roots? Okay, and neither one of them work, right, guys? Okay, all right, that's okay, that's all right. That's okay. So I don't have any rational, so basically that thing doesn't factor, so I'm not gonna be able to cancel, so I'm not gonna have any holes. All right, I at least have a y-intercept, don't I? And I have a vertical asymptote. So I have a vertical asymptote at 1. What's my y-intercept? Putting in zeros. -1. All right, what did I get?
Did you find the slant element?
Well, I'm going to have to, but the slant asymptote this time is gonna look a little different, because when I do this division, I think I already did this division actually. When I do that, what is left? It's a quadratic. It's y equals x squared minus 2x plus 1.
So you can still disregard the remainder.
Always disregard the remainder. When you're finding the end behavior asymptote, the remainder is irrelevant.
So then it'll be,
But the end behavior asymptote does not have to be a line. The end behavior asymptote can be any kind of shape, and in this case, it's going to be a parabola. Now, isn't this x minus 1 squared? So that is a parabola whose vertex is where?
One.
At 1, 0, and which opens up. Would you agree with that? All right. Let's see. I need to check something out here. When I put in 1, I got 2. Anybody remember what I got when I put in -1? I can't
I
remember.
think you got, it was 7 and then.
So -6. That's what I got. Okay, so -1 gives me -6. I'm just trying to plot some points to get a sense of what this thing looks like. Oh, wait, no, that's not right. I forgot. I got the whole problem. So that's not right. That's not right. So -1 gives me -6 over -2 gives me 3. So -1 gives me 3. And that parabola on -1 gives me 4, 6 under here. Okay. All right. Yeah, I need to know what happens if I put in a number like 1/2. So that's gonna be, I'm really just interested in positive or negative, so it's gonna be 1/8 minus 3/4 plus 3/2 plus 1 over -1/2, okay. This is going to be positive over negative. Would you agree with me that that'll be a positive number? And that's a negative, so when I put in 1/2, I get a negative. Okay, now wait a second. These 3 dots have to be connected. Not sure what the curvature is in there, but those dots have to be connected. Does that make sense to you?
Mm-hmm.
So now I've got, there's a 0 in here. What do I know about that 0? No, it's not a hole. I shouldn't do that. It's not a hole. It's irrational, right? It's irrational. Because it's not 1 or -1, it's some decimal in there. That I could use my calculator to find, but I'm trying to do this without a calculator. So I don't know what that point is, but it's irrational. It has to cross because that was a positive and that was a negative and that's a negative, so it's gotta cross. All right, there's another piece to this. There's something on this side.
Would it be
It would be
under the parabola?
I don't know. How could I tell?
because
I'll just pick a point. So that's 1. What happens if I put in 2? So putting 2 into my problem gives me 8 minus 12 plus 6 plus 1 over 1. Is that positive or negative? Oh, it's positive and I need to know what it is actually. So it's 7, 3. So 1 or 2, excuse me. 2, right? 2 gives me 3. Now Now remember, if you plug 2 into your asymptote, you get 1. So this point is above the asymptote.
So then would it have to be in between?
Yep,
Okay.
it looks like that. It looks like that. Very strange. Very strange. That's what it looks like. Now, what's the moral of that story? That's actually a great problem. What's the moral of that story? 2 things. First of all, in behavior asymptotes can be any shape. And second of all, sometimes you just gotta plot points to figure out what's going on. Right? Just gotta plot them to figure out what's happening. Okay. All right, one more of those and then we're done with 2-6. All right, any question about that before I erase it all? Everybody follow all those steps, all that messing around, Ben?
On that left line, like, what does it look like when it goes to infinity, like negative infinity? Does it like trace the parabola? Or
Yep.
does it go up?
Yep.
So it like goes like that?
Yep.
Okay. All right.
Yep, it just keeps curving out, 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 just like the parabola does.
Okay.
And the same thing here. So this one's following that too, doing the same thing. Okay. All right, last one. Here we go. Let's see what we got. Okay. So let's see. Do you have any factoring in this one? X minus 1, X plus 3. Oh shoot. We got factoring, but we have no canceling. So we will not have any holes. We do have a vertical asymptote at -2. We do have intercepts, x-intercepts at 1 and -3. Remember, when you set your problem equal to 0, you're really solving the numerator. Okay. What about a y-intercept? Is that -3/2? If I put in 0? All right, everybody keeping up? I feel like we're kind of going fast on this one. Everybody okay with that? All right, so now I need my end behavior asymptote. Now I look at my original problem, and I notice that the power on top is bigger, so I'm going to have to do my division. So I'm putting my -2 out here in the box, and here I go. So my asymptote is going to be y equals x, my end behavior asymptote, which is this right here. Oh, I think this is an easy one. Don't the points that we have kind of tell us what's happening here? These got to be connected, so aren't we going down like this and coming out like this? And then over here, since we have that point's got to be part of the curve, coming down like this and going up like this. Oh, that was an easy one, says the teacher. Do you think that's easy? Does that seem easy?
It's definitely easier than the previous one.
Very much easier than the previous one. Any issues with that? Okay, perfect. This one will be Tuesday. 126 is Tuesday. All right, we're gonna go ahead and start 2-7. Which is not graphing. Seven is solving. So we're now on page 31, we're looking at section 2.7, we're gonna solve some rational equations. All right, who's got a plan? Mr. Bernauer.
You can multiply everything by x.
I would multiply everything by x, yep. I think most of us do not like dealing with fractions, and so if we can get rid of the fractions, let's just do that. So if we multiply everything by x, our equation is x squared plus 3 equals 4x. Right? If we just multiply everything by x. The whole purpose of that is to cancel out the denominator so you have no more fractions. All right, what do we got now? We have a handy dandy little quadratic equation, which of course we will set equal to 0 and then solve however we want. If it factors, we can factor it, we can complete the square, we can use the quadratic formula. I think this one actually factors.
Yep.
So we end up getting 3 and 1 as the answers to the equation. Now, there is one thing you have to think about. Doesn't pertain to this particular problem, but when you have a rational equation, you have to think about what we call excluded values, right? Because no matter what happens in this equation, x cannot be 0. So if by chance we had solved the equation and gotten 0 as a root, we'd have to throw it out. Now, it didn't happen for us, but we should always keep this in the back of our mind. All right, let's look at the next one. So what am I thinking in the back of my mind for this problem? Whatever x is, it cannot be 4, right? So I don't know what the answer is going to be, but if it turns out to be 4, I have to cross that out. That's excluded. You're going to do the entire thing by x minus 4, that's right. And you're doing both sides, but the beautiful thing about a 0 is it really doesn't matter over there. So I'm going to have, these are going to cancel. So I'm going to have x squared minus 4x plus 1 equals 0. So I got another beautiful little quadratic. It doesn't factor, right? So I'm going to have to either complete the square or use the quadratic formula. I haven't completed the square in a long time, and this would be an easy one. So solve it however you want. It really doesn't matter. I think I'll complete the square just to practice. So remember, I'm going to move the 1 over. Half of this squared. Half of this squared. So no matter how you solved it, you should have gotten these as your answers. If you don't want to complete the square, that's fine. In chapter 8, you're going to have to, so try to keep it somewhat fresh still. But you can always use the quadratic formula with that. Again, no worries, we didn't get 4, but it's good to keep that in the back of our mind. Any question? Everybody good? Okay, we're just gonna keep rolling until you stop me. My father said, we're joyful today. We are joyful. We're doing rational equations. Makes us joyful. Is it okay with you if I go ahead and factor the denominator of that last fraction? And of course, this is a highly rigged problem because notice that the factors of that last one are the other denominators. So it's going to be easy to clear these denominators. We're going to multiply everything by x minus 3 and x minus 1. Everything by x minus 3 and x minus 1. remember that the reason you did that is to cancel your denominators. There are no denominators left. You got rid of them all. What you do have left is 2x minus 6 plus x minus 1 equal to 2. So 3x minus 7 equals 2. So 3x is 9 and x is 3. Your little extraneous radar are up, because in the beginning you noted that x can't be 1 and x can't be 3. So we got 3. Can't be 3, so this problem has no solutions. The only answer we got didn't work. All right. See how far you can get with this next one. I'm going to put my attendance in. You go ahead and get started on it, and then we'll come back together and figure out how we did. By the way, I got your grades finalized, I think, so you might want to check and make sure I didn't make any mistakes. Okay, well, nobody's. Okay, how you coming? I don't know if you can see the comments at this point or not in the grade card, but when you get your grade card, you need to know the comment.
Oh, yeah.
Talks too much. Okay, so hopefully you have multiplied everything by x and x plus 2. I know that's under the TV. Again, that's a 0 on the right side, so it doesn't really matter, but if that's another number, please remember to multiply on that side also. Okay, I got 0 and -2. But neither of those works because in the beginning, I got an x in the denominator, so no 0. And I got an x plus 2, so no -2. So this one also has no solutions. Now, it is possible that you'll get one of them to work, but sometimes they have one answer, sometimes both work. This is a case where neither one works. Everybody okay with that? Okay, all right, let's start in on some word problems here. Oh, some of these look kind of reviewish. Let's see, number 2. How much pure acid must be added to 50 milliliters? You hate these problems? All right, this sounds like amount times percent plus amount times percent equals amount times percent. So what do I know? At least in these problems, sir, we always know a lot. So we know how much pure acid, what's the percentage for pure acid?
100.
100 or 1.00 must be added to 50 milliliters of 35% acid to produce a mixture that is 75%. Now, do all of those numbers make sense to you? They're straight from the problem. I mean, I put an X here, how much? All right, now, this blank is missing. This is the amount of the final solution. So let's just use our common sense. What have we mixed together? Like how much of each have we mixed together here? X milliliters and 50 milliliters. So how much we have? X plus 50, yeah? Doesn't that make sense to everybody? If you got a bucket and you dump in X and 50, don't you have X plus 50 in there? So X plus, oh, I should be able to do that. I just don't have the energy, so I'm gonna find my calculator. I'll tell you, when you get old,
Well, it comes out nice on it.
it's lost. 50 times 0.35, 17.5. 0.75x plus 37.5, somewhere there's an equals. Okay, we all right so far? So 0.25x equals 20. I got 80. Everybody okay with that? Yes.
Why is like the pure acid just 1?
Well, I want to know what percent acid it is. And if it's pure acid, that means it's 100% acid, right? Pure of anything is 100% of that thing. So it's not like this, which is 35% acid. This is like a weaker solution. This is straight acid, so it's 100%. All right, is that okay? Thanks. All right, number 3, find the dimensions of a rectangle with minimum perimeter if its area is 200 square meters, right? So I have a rectangle, and I want to find, okay, I know the area is 200, and I want to find the perimeter. And I actually want to find the minimum perimeter. All right, so who's got an idea? Bronson?
So I think you can start out by creating the two equations that you're given, which would be length times width equals 200
All
for the
right,
area.
so length times width equals 200. Would everybody agree with that? Length times width, okay?
And then with the perimeter, that would be 2 length plus 2 width equals an unknown.
Okay.
And then from there, I would, like either isolate, in the area problem, I would either isolate length or width by dividing out the other one.
Okay, so what you're saying is, if this is X, this is gonna be 200 over X. If this is L, it's 200 over L. If it's W, it's 200 over W, whatever letter you wanna use. That looks pretty good, doesn't it? So now I need, okay, so now I can do my perimeter. So 2 of my lengths would be 400 over X, 2 of those, plus 2 of these. And that's my perimeter, that's my Y that I'm trying to minimize.
Why did you put 400 over 2 of these?
Because when you multiply by 2, you're multiplying by 2 over 1. Right? Now I need the minimum value of that. Now what you can't do, guys, is say, oh, I'll just multiply everything by X. You can't do that because this is not a number, right? That's not like a 0 or something, that's a Y. I need to figure out what that Y is. So I'm gonna go to my calculator and I'm gonna graph this equation and find the minimum. Now, I don't know what your window is set. I'm set for box problems. I did those in another class. So I'm gonna change this up a little bit. You're not gonna get a parabola shape. This is not a quadratic. I got something that looks a little bit like a check mark. Play around with your window. I actually used, if you're struggling, this is not sacred at all. This is kind of, I just happened, I got 0 and 50 and 0 and 200, and it gave me a shape like that. So now I'll find my minimum, second calc, minimum. Now I want to make sure I answer the question. I can't remember what the question was. But I'm gonna get a minimum, and that minimum is gonna be, I got 14.14 and 56.57. Anybody else get that?
Yep.
Okay. Now, let's answer the question. The question is, find the dimensions and then find the least perimeter. So remember when you set up your equation, what did you let X stand for? What was X? One of the dimensions, right?
Length or width.
So if it says, what are the dimensions, it would be 14.14 by, how am I gonna find the other dimension? 200 divided by that number? Oh my gosh, what happened? Didn't you get the same thing?
It's a square.
Which means it's a square? The rectangle with minimum perimeter is a square? Interesting. And then, what is the perimeter? Well, isn't this number the perimeter?
Mm-hmm.
Because Y we set up as the perimeter, so 56.57. And
So
I need
then-
units on this, I can't remember what they were.
So then could we possibly just do square root of 200?
Yep. But I didn't know that was gonna happen until I did all this anyway. But yeah, the square root. Is that okay? All right, we're gonna do one more. This one's a little bit more interesting. There we go. Stewart Cannery will package tomato juice in 2-liter cylindrical cans. Find the radius and height of the cans if the cans have a surface area of 1,000 square centimeters. All my job is to find the radius and the height of the can. And I know the volume of the can is 2 liters. And the surface area is 1,000 square centimeters. So the surface area is 1,000 square centimeters. Okay. Where do we even begin? Bronson?
I would start with getting like the basic formulas for each of them.
Just like we did with this problem. So the basic formula for volume of a can or a cylinder is,
Pi r squared times height.
yeah, that's my volume equation. Now, surface area of a cylinder,
Height times base plus the base.
remember the cylinder, use your imagination.
circumference.
The cylinder has 2 circles, right? So that would be 2 pi r squared.
Maybe a rectangle.
That's the 2. And then, exactly, if you were to cut this, yeah, this is better. Here's my cylinder, right? If I open it up, isn't it just a rectangle? And this is the height of the cylinder. And if I put it back together, isn't this the circumference? When you open it up? So that is gonna be plus 2 pi, or no, plus, yeah, 2 pi r h, because 2 pi r is the, oh, thank you. Okay, so it's 2 pi r times h,
Why would you use pi for a rectangle?
because, remember, the circumference is 2 pi r,
Mm-hmm.
and when you open that up, that's still 2 pi r. All right, so Bronson, we got our equations. And I don't know if there's anything else, this is bothering me a little bit. I got a mixture of units here. Is there a way to make those the same? Mr. Whalen? Yes, yeah, cubic centimeters. So what do we know, what's the relationship between cubic centimeters and, what's a cubic centimeter the same as? A milliliter. So a milliliter is the same as a cubic centimeter, right? So can I say this is 2,000 milliliters, which would be 2,000 cubic centimeters, which will make it match units anyway, right? Is that okay with everybody? All right. Now, I know that the surface area is 1,000. So I'm gonna go ahead and put that right here into this formula that Bronson had us develop. Can I solve that equation for h? Can I get h by itself? And then take that h value and plug it in here and come up with an expression for the volume? Oh, wait a minute, I know the volume too, don't I? Oh, so I know 2,000 equals pi r squared h.
That'd be easier to do that one.
I think I want to do what I was talking about anyway, because don't I have a system of equations here? And I need to solve that system, so yeah, which one do you want to do? Get this h by itself?
Yeah.
So h equals 2,000 over pi r squared. And I put that here then? Alright, I gotta erase something. So I'm gonna have 1,000 equals 2 pi r squared plus 2 pi r times 2,000 over pi r squared. I'm taking this h value from my second equation, my volume equation. I'm taking that h value and plugging it into my surface area equation. So basically I'm doing substitution with this system of equations. So what happens here? Looks like something good's gonna happen there. Pi's are gonna cancel. One of the r's is going to cancel, and I can multiply and get 4,000 over r, is that it? So now I have an equation basically, well, I can leave it like that if I want, or I could subtract the 1,000 over. Really doesn't matter. If you leave it like this, you would graph this on your calculator and this on your calculator and look where they cross. If you move this over and set it equal to 0, you would graph all that and look where it crossed the x-axis. So it's whatever flips your switch. You gotta find an r value out of that somehow. So I'm just gonna leave it like this.
For R, do you see that?
Yeah, yeah. Yeah, your variable is gonna be x. Make sure you're using your pi button. And I have no idea about a window, so mine's not right.
So you do it, that's, no, one. Yes, it is. I mean, X, I mean, my.
Now, again, I am graphing it as two separate equations, but my window that gave me a decent picture is 0 to 20 on the x's and 0 to 1,500 on the y's, and that gave me something like this.
Did you do?
I haven't done it yet. I'm too busy messing around here. Let me get it.
1.61462.
Okay, let me write that down. So, Sir got this one here, 4.62, and that would be comma 1,000. What did you get for this one? You got that one yet?
No.
Yep, I got 4.62 right, good. 9.65 for the other one. All right, those of you that are sitting back there just kind of listening, anybody else matching those numbers? I haven't gotten the second one yet. That's what you got? All right, so let's answer the question. Those are the intersections, 9.65, that's perfect. The question is, find the radius and height of the cans. So what are these numbers? Those are the radius. So how are we gonna find the height? Well, I erased it, but didn't we say that the height was 2,000 divided by pi r squared? Isn't that what we used as our height substitution? So we'll take 2,000 and divide it by pi times 4.62 squared. Be careful. Be careful. When you're dividing by two things, you gotta have it in parentheses. So pi times 4.62 squared. Did you get 29.83? And for the other one, $6.84. So if you are Stewart Cannery, what's your decision then between, both these cans will suit your purposes, what does this can look like? It's a taller can, taller and skinnier can, what's this one look like? Very short and wide, so it's your decision as the cannery manager, what you wanna do with it. All right, woo!